Okay, Assalamualaikum. Welcome back, everyone. So now um continuing um our Q and answer or question and answer, and then now we are still on the same topics, which is discussing uh about the stoichiometry and chemical reaction. So now we are trying to continue from the previous question that we already done. Now we move on to number 20. So let's get started to answer all of those questions together. All right. Before we continue, just for your information, guys, that this one is ACS exam, like the standardization of the exam standard in the US for chemistry. So I think like for most of student like facing this exam before they graduate or before they want to continue their PhD. So like they have kind of like requirement to pass this exam. All right. So now we are in the question 20. Which compound contains the largest percent by mass of oxygen? Okay. So um what we need to know first is the molecular mass. The mass was that the molar mass. Sorry, molar mass for each molar mass of each was that element. Okay, molar mass for each element, which is CO2. For molar mass, CO2 is 44.01 gram per mole. For NO2 is 46, okay, 46.01 gram per mole. For SO2, so we can get this answer by looking at the periodic table. So like so easy, just take a look at one by one of atom and then just adding it up to get all together. Okay, adding up all together. SO2, so SO2 is 64.07. Okay, let's pause little bit just for hearing other. Right. So, all right. So we done. Now we are. So I already wrote all of those smaller mass, all of those compound. So now, because of the O2 is same, the number of O2 is same, 2, 2, 2, 2 for each element, for each compound. So now, how to get it so fast? I mean, how to get it quickly? So just by take a look at which one that the least, okay, which one that the least or the lighter of the molecules, okay, the lighter of the molecules. Okay, so which one that the latest one? I mean, the like the not the like the lightest one. So the lightest one is CO2. So the answer is CO2. But how to do calculate one by one is pretty easy. So we just need to know O2, the molecule, the was that the O mass. So the oxygen mass is 32, right? 32 for each compound. So just 32 divided by 44.0 100%. So the answer for this one is 72.7%. So because of this one is the lowest one, okay, the lowest one, so CO2 will be, I mean, oxygen in CO2, which will be like containing the largest percent of oxygen. Because of what? Because this one is the least, like the lightest one, okay, the lightest one. Okay, so number 21. Which compound has the highest percent composition by mass of oxygen? Which compound has the highest percent composition by mass of oxygen? And remember, like the previous concept, we need to know like how many atoms, how many oxygen for each compound. All of them is 3. Okay, all of them are 3 oxygen. So which is this one is like much more easier for us to solve that problem. And then what we need to do next is just looking like sum up all of them element, okay, sum up all of them element one by one, and then we need to know which one that the lightest one, okay, the lightest one, same as the oxygen, same as like the previous one. Look for like metals, okay, look for like the lighter one, okay, because what we need to know here is the oxygen. All right, so let's break down it, let's break down it one by one. Okay, so for the first one, CaCO3, the molar mass is, I already calculated, 100.09. For CaSO3, 120.5. For lithium, like the lithium CO3 is just 73.89. And then the last one is for the last one is 91.95. So based on this information, because since the oxygen all of each component of each compound have same amount, which is 3, okay, so now we only care about the the total molar mass. Okay, so which one the light one, the lightest one, which one? Simply, the simple answer is C. Okay, yeah, that's correct. The answer is C. Because of what? Because, okay, because of what? Because this one is the lowest one. Okay, Le2CO3. All right, so now we are move. So the highest one, okay, the highest one. Okay, so higher if we want to know the higher composition, if the compound that's same, I mean the compound we need to take a look at is same, we need to understand one by one. Okay. All right, so the answer is should be C. All right, and then we are moving on to another part, which is the number 22. Number 22, okay, number 22, 10,000 gram of sample waters contains 11.19 H by mass. What should be percentage H into 20,000 gram sample of water? So, 10,000 gram of water contain 11%. And then, remember that H2O in 10,000 gram is only 11.19%. Okay, is only 11.90%. How about if H2O is 20,000 gram? Like which like how much percentage? Okay, just remember, percentage, okay, doesn't change with the sample size. Remember, percentage doesn't change. Remember, percentage doesn't change with sample size. Just remember that one. Okay, just remember that one. So the answer is still same. The percentage still same. B. Okay, so if you remember percentage, how to calculate percent is part divided by whole times 100%. Okay, if the ratio of part is still same, which means this is 2, this is also 2, the percentage, I mean the percent is still same no matter the amount. Okay, no matter the amount. Okay, just remember, because of the ratio between the first and then the second is same, which mean both have 2 hydrogen, the percentage, the ratio is still same, so there is no change for percent. Okay, there is no change for percent composition, so still remaining one 11.19. Okay, this is the concept. Okay, remember, this one is so important. Remember that percent composition doesn't change with sample size as long as the ratio still same. All right. Okay, remember that part. Okay, now we are moving to another part. So we're gonna move to number 23. Okay, so we almost done for all of question. Just 2 slide more, 2 slide left. All right, so number 23. What is the percentage of oxygen in this element, in this compound? Okay, it's in this compound. So what we need to do now, we need to know the molar mass, the total of molar mass. The total of molar mass, okay, the total of molar mass is what? 399.91 gram per mole. So what's the mass percent of oxygen? How many oxygen over there is 12? Okay, there is a 12 oxygen. Okay, so how about the total of molar mass? If we have 16 times 16 times what? 12. So the answer is time 12, 12, 3, 6, 1, so 192. And then what's the percentage? It's very easy. 192 divided by 192 over 399.91, 100%. So the mass percent of oxygen is, just by doing calculation, 48.01%. Okay, so the answer is D. It's very easy for this one. I think the previous videos, I mean the previous session, we have like much more difficult part. So it's kind of like sometimes like kind of like getting confused, but as long as we practice more and more, we will get used to solving that problems. All right. And then number 24, what is the percent by mass of oxygen in CaNO3 2? Same as the previous one. So what's the molar mass of this one? The total of molar mass this one is 164.1 gram per mole. And then after that, we just going through the calculation. And then as you know, the total is 6. Okay, the total is 6. So 6 times 12 is 72 per 164.19, 100 per percent. So the answer is should be oh wait, no, 16, oh 12 6. Wait, let's take a look at. So let me calculate manual. Number 24, the total molar mass is 100. Okay, and then mass of, oh, this is mass, oh, percent by mass, sorry, not not like the previous one. I'm so sorry, because the answer is should be kind of like a little bit deep. No way. Oh no, it should be same, so oh 6, sorry, oh, it should be 16. 16 times 6, it should be 96, right? 96, and then divided by 164, 19, so it should be 58.5%. So the answer is should be C. I'm so sorry, guys, because sometimes I do wrong calculation. All right, it's okay. Which compound contains the greatest percentage of nitrogen? Okay, let's take a look at one by one option. Okay, one by one of the option. So when we know regarding this option, okay, regarding this option, guys, so we know that all of option n is just one. Okay, n is just one. So like the previous one, we need to take a look at which one that has the lowest mass molar. Okay, molar mass, which one that the lowest molar mass, which one it is. Let's calculate one by one. For KNO3, the molar mass is 101.11, and then KNO2 is 85.11, and then NaNO3 85, and then the last one is 69. Okay, so which one that the lowest one for the molar mass? Okay, the answer is should be D. Okay, if we were gonna do one by one, it's pretty simple. Just how about the molar mass of nitrogen is 14? Okay, and then divided, for example, for the option A is 101.11, and then times 100%, and then we're gonna get the answer. The equation is the greatest one, not the lowest one. Okay, the greatest one. If we're gonna looking at the lowest one, if we gonna if we wants to know, if we want, if we wanna know which one that the lowest, what we need to choose is the highest molar mass. Yes, that's true. Okay, so the first one is the lowest percentage of nitrogen. Okay, now the question roll on for the next question. What is the mass percent of carbon in isooctane, a common component of gasoline? Okay, we can take a look at this part. What is the mass percent of in isooctane? So we need to take a look at one by one. Ca, okay, and then H or 18. So if we're gonna look at the molar mass of each item, so 8 times 12. Okay, 96. This one is 18, still 18. Okay, then 18. So just adding up all together, it becomes 14 and then 10, 11. Okay, so this is the total molar mass. Okay, now we just do some calculation like this one, and then 100%. So the answer is should be 84% when we are looking at when we just do calculation. Okay, now we almost done for 30 question, all of them together. All right, now we are moving on the next question. What is the empirical formula of compound carbon, hydrogen, oxygen that contains 51% carbon? Okay, 51% carbon and then 14 hydrogen. So the rest one should be 56 and 56 and then 0.9. Okay, let's take a look at, so how to get the oxygen is pretty easy. Just 100 minus 51.56 and then 14.09, and then we will ended up getting the answer. 100 minus 51.56 minus 14.09. So let me 51.56 minus 14.09. So the answer is 34.44. This one is for oxygen. Okay, this one is for oxygen. Okay, now it's done? Not yet. Not yet. We have to take a look at mole of each compound. Okay, just assume this one is mass itself. Mass itself. So how to do calculation of this one is pretty easy. How to do this one is pretty easy. Just what? Just do by calculation. I mean, just using calculation for C, gram per mr. So 51.56 divided by over 12, and then H still same 14.09, and then for O 34.44 over 16. So we ended up getting the answer of that one. 51.56 divided by 12. So the answer is should be around 4.3 probably. And then this is 14.09. And then how about the last one? 34.44 minus divide over 16. 2.15. Now let's bring this one together. Okay, let's bring this one together. How to do that? Just make it 1 for the lowest one. So this one 2.15, 2.15, and this one 2.15. So O, it should be 1. Okay, O, it should be 1. And then H, how about H? Let me take a look at 14.09 divided by 2.15. So the answer is around 6.5. And then how about C? C is around what? 4.3 divided by 2.15. So the C is 2, is around 2. So based on this information, we get the answer of the equation, the empirical formula. So now we just wants to get like maybe C4 H13O2. This is the answer probably. Yep. It's good. This is the answer. We got it. Okay, we got it. So it's pretty simple as long as we understand the concept. Now, number 28. Tetrahydrocannabinol, the active agent in marijuana, contains blah blah blah, hydrogen and oxygen. What is the empirical formula? still same thing. Okay, still same thing like the previous one. So just make it simple. 80.16 divided by over 12. Okay, and then H 9.63 because the mass is just one, right? We don't need to calculate anymore for hydrogen. And then for oxygen is 10.17 divided by 16. Now we gonna do one by one calculation, right? uh 80 80.19 divided by 12, 6.68, and then 10 by 7 divided by 16, 0.635. Right, that's good. That's good. Which one that the lowest one? Which one that the lowest one? That's the most important. This one. So it should be 0. And then let's take a look at for another one. 6.68 divided by 0.635. So it's around 10.5. How about this one? 9.63 divided by 0.635 is around 15.16. So this is one. Okay, so the answer is kind of like C, probably C 10.5 H 15, and then O is 1, just like kind of like this one, or C 11, no, 21, yeah, H 30, and then O 2, because we times 2. Okay, so the answer is should be C. It's pretty easy, right? Number 28. So, and then what's the empirical formula for a compound that comprise still same thing like the previous one? Okay, so 45 sodium, okay, Na, and then just divided by what the was that the molar mass is around 22, right? 22.99, so it's around like 2.35. How about the boron? Boron itself is 8.5% divided by 10.81, so it's around 0.786. And then the last one is oxygen. Oxygen is 37.5. 37.5 divided by 18, right? Divided by 16, sorry. It should be around 0. No, it should be 2.34. And then we need to do much more calculation over here, because we need to use the lowest one. Which one that the lowest one? It's pretty easy. The lowest one is this one, so 0.786, 0.786, and then this one as well. So boron, it should be 1. How about this one is let's take a look at, let's do calculation. 2.35 divided by 0.78, so it's 3. And then how about this one again? Is around 3, I think. Same thing. So the answer, it should be Na3PO3. So the answer is B. Yeah, that's good. That's good. And then the last question for today: a molecular compound is found to consist 30 nitrogen. Okay. Nitrogen. Okay, sorry. 30.4% nitrogen, and then O is 96.6%. If molecule contains 2 atom nitrogen, if molecule contain and 2 nitrogen, what is the molar mass of the molecule? Okay, what is the molar mass of the molecule? How to answer this question? Okay, how to answer of this question? It's pretty easy if we know. Okay, if we know this is already have the we have already have this composition, right? So how to could do that? Just assume the total is 1. Okay, total is 1. So nitrogen, how about the nitrogen is 14. Okay, 30 nitrogen is 30.4 divided by nitrogen is 14, so they're around 2.17 mole. How about the oxygen? Still 69.9 divided by 16 is around 4.35. So if we are looking at this point, so it's kind of like this one, it should be 1, right? This one, it should be 1. This one is around 2. So the empirical formula is NO2. This is the empirical one. But if the molecule contains 2 nitrogen, so O, it should be 4. So what is the molar mass of the molecule? So just adding 14, this is 28 plus 16 times 4 is 64. So the answer is should be B, right? Okay, so the answer is should be this one. All right, that's done. That's all, guys, for us for the molar mass, and then kind of like stuff like molar mass, stoichiometry stuff. And then next part is real stoichiometry. We're gonna do some reaction, and then we need to determine like which one that which one that already complete, already finished, something kind of like that. So and then we need to balance a chemical reaction equation as well. So it's much more complicated, but as long as we understand the concept like I mentioned, we good. Okay, we good. So don't try to memorize everything, but just try to memorize. It's good, but try to understand the concept behind it. All right, so bye bye for this session. Hopefully I can do soon for the next session about stoichiometry and other stuff about the balance of equation, and then balance of chemical reaction, determine mole ratio, and then convert from mole to mass and other stuff. So okay, see ya, bye bye, assalamualaikum.